Okay, this is exercise 3C from that at the end of your graphs booklet, the one that we were doing yesterday. Exercise 3C from your graphs booklet. Okay, question 8. I just want to look at this one. So in the given diagram, the curve y equals sine 2x, notice that the period of y equals sine 2x is 2 pi on 2, which is pi. So see, you can see that the period is pi. Okay, so it's being graphed from negative pi, so up to pi, and then back to negative pi. Okay, and then the line y equals half x minus 4 is also graphed. Now y equals a half x minus 4, obviously positive gradient of 1 over 2, and the y-intercept is negative a quarter. Now it says, the first question is, in how many points does the line y equals a half x minus 4 meet the curve y equals sine 2x? Now I'm just going to put those points of intersection. We've got 1, 2, 3. So there are 3 points where the line meets the curve. In other words, if you were to solve that equation using normal methods, say simultaneously, you would expect 3 solutions, and the first solution would be a bit less than x is pi on 4. The second solution would be x is negative, I don't know, well, it's less than negative pi on 4. It's quite small, it's close to 0. And the third solution would be close to negative pi on 2. Okay, so in how many points does the line meet the curve? It's 3. State the number of solutions of the equation sine 2x, and that's solving simultaneously, equals a half x minus 4. We've got 3 solutions, so 3 solutions. And how many of those are positive? One of them has a positive x value. We're not worried about the y values, but remember, solutions will be x equals, x equals, x equals. We have one solution where x is positive. And there are 2 solutions where x is less than 0. So 2 negative solutions for x and 1 positive solution for x. And then the last question is, briefly explain why the line y equals a half x minus a quarter will not meet the curve y equals sine 2x outside the domain from negative pi to pi. Notice that this curve will just continue, or the straight line will continue up, and this line will continue down there. The reason this is, it's got to do with the amplitude. So the amplitude of sine 2x equals 1. So in other words, the values, the y values for sine 2x are between negative 1 and positive 1. And after values of pi, the values for the line, the straight line, will be, so we can also put for y greater than pi, for x values greater than pi, y, for the straight line curve, y equals a half x minus a quarter will always be greater than 1. So the y values will always be greater than 1. So for values of x greater than pi, half x minus a quarter will be greater than 1. And for x values less than negative pi, a half x minus a quarter will be less than negative 1. So these values, the y values for these, are less than negative 1, and hence the 2 graphs will not meet. Okay, so you need to talk about the amplitude just between negative 1 and 1, and for x values greater than pi, so I'll just redo that. So I've got also here, for x greater than pi, the value of a half x minus a quarter will be greater than 1. And for x values less than negative pi, so as we come down here, the y values for this straight line are less than negative 1. Hence the 2 graphs will never meet. Okay? Now we're looking at question 9. Now, we've got the graph y equals sine of x here. Now, y equals sine x has a period of 2 pi. Notice it's got pi. You know pi is approximately 3.14. What they've done on this scale, you actually get your calculator and you work out, you can put values of 1 and 2 and everything in. Remember, we're working in radians, so pi is 3.14. It's not 180 degrees, okay? So if you want to see what pi on 2 is, I've just got my calculator here. Pi divided by 2 is 1.57. So if we see here pi on 2, if this is 1 and this is 2, this is 1.5, this is approximately 1.57. Pi on 2, sine of pi on 2 is same as sine 90, which is 1. So on this x-axis, where we've got pi and pi on 2, the values that we're filling in between are so pi on 2 here is approximately, as I said, 1.57. Okay, pi here is approximately 3.14. Okay, negative pi on 2 is approximately negative 1.57, and negative pi is approximately negative 3.14. Okay, so now we've been asked to graph the line y equals a half x. So for y equals a half x, when x is 0, just doing a table of values here, when x is 0, y is 0. When x is 2, 2 times a half is 1, so that's probably the best value to do. When x is 0, y is 0. When x is 2, y is 1. And I'm going to do also when x is negative 2, a half of negative 2 is negative 1. Remember, for a straight line, you only need 3 points. Negative 2, it's negative 1. I wouldn't be doing other values, otherwise you're not going to get a very accurate graph. But if you choose the values of 2 and 1, 2 and negative 2, you are going to be able to plot the points 2, 1 and negative 2, negative 1, and you'll get quite a good graph. So now I'm going to draw a straight line between those 3 points. Okay, so that is my line of y equals a half x. Okay, so that's y equals a half x. Now this is similar to the question before, but the graph was already drawn in the question before. Here I've just talked about this scale here, and y, this is 3, and pi is 3.14, and pi and 2 is approximately 1.57, lying between 1 and 2, okay? So hence find the 3 solutions of the equation sine x equals half x. In other words, we're looking for the points of intersection here. Now I've got one there, 1 point there, and 1 here, giving your answers to 1 decimal place where necessary. So the solutions are x is, well, to me it looks like negative 1.9, the x value here. Here we've got x is 0, and here it's approximately x is positive 1.9. Okay, I can just write 1.9 instead of positive 1.9, and that's giving the answers to 1 decimal place. Solutions, I'm going to put x is approximately equal to negative 1.9. It actually does, and it's approximately equal to 1.9 as well, and x is definitely equal to 0. Okay, so the negative 1.9 and the 1.9 are approximations, so approximately equal to, and x equals 0 is an exact solution. Now I'm going to look at question 11. That'll be the last one we'll do from this exercise, and then we might look at exercise 5.8. Okay, now it says to carefully sketch the curve y equals sine squared x from 0 to 2 pi after completing the table. So remember, sine squared x, that would be sine of x is 0, and squaring 0, you get 0 squared is 0. So sine of pi on 4, the sine of pi on 4 is 1 on root 2. So we're doing 1 on root 2 squared, so my answer is a half. Okay, so I'm just showing the working up there. Sine of pi on 2, now sine of pi on 2 is the same as sine 90, which is 1. Okay, what I'll just do, I'll do a quick sketch of the sine curve. Okay, that's 2 pi, that's pi. So sine of pi on 2 is 1, so 1 squared is 1. Sine of 3 pi on 4 is here. Sine of 3 pi and 4 is also 1 on root 2 squared, which is a half. And sine of pi is 0, so 0 squared is 0. So I'm going to keep going, okay, because we're asked to sketch it from 0 to 2 pi. So we've got 5 pi on 4, we've got 3 pi on 2, 7 pi on 4, and 2 pi. Now, sine of 3 pi and 4 would be negative 1 on root 2 squared. And when you square that, you get a half. Sine of 3 pi on 2 is negative 1, so square that and you get 1. Sine of 7 pi on 4 would be negative 1 on root 2. Squaring that, you get a half. Sorry. And sine of 2 pi is 0, so 0 squared is also 0. So now I'm going to sketch this curve, y equals sine squared x. So here, y equals sine squared x from 0 to 2 pi. So we've got 0, pi on 4, pi on 2, 3 pi on 4, pi, 5 pi on 4, 3 pi on 2, 7 pi on 4, and 2 pi. Now, let's put in all our zeros. We've got 0 at 0, we've got 0 at pi, and we've got 0 at 2 pi. And amplitude is 1 here, and we also seem to have this value of a half that appears. So when x is pi on 4, sine squared x is a half. When x is pi on 2, sine squared x is 1. When x is 3 pi on 4, we've got a half. For pi, it's 0. So it appears to go like this. Now, 5 pi on 4, I get a half again. See, normally the curve would be coming down, but it actually bounces back up. 3 pi on 2 gives me 1, 7 pi on 4 is a half, and the last one's 0. Now, I would be just, see, this is sort of all concave down, so make sure it looks like that, and this is also concave down, so do not come down and come back up, okay? Because normally the curve would come back down, but basically because it's squared, it's been turned back over that way, okay? So that's question part A, 11A, is to sketch y equals sine squared x. And then it says explain why y equals sine squared x has the range, or y values from 0 to 1. It's because any negative values, it's because negative values squared become positive. And so any negative values squared become positive, but also y equals sine x has a range from negative 1 through to 1. So therefore, y equals sine squared x will have a range, from 0 through to 1, because the negative values squared, because negative fractions which lie between 0 and negative 1, lying from negative 1 through to 0, when they are squared, will have a value from 0 through to 1. Okay, so that's part B. And the period and the amplitude of y equals sine squared x. So the period is how long it takes for the curve to repeat. So the period is pi, because this does go down like that, and then we've got the same shape, so it doesn't curve back down. And the amplitude is not 1. It's the distance from the center of the curve up and down. Okay, so the amplitude is actually a half. Okay, and that's the end of question 11. from exercise 3C worksheet. Homework, could you please do exercise 3C, questions 6 and 7, and question 12 down there, and question 13 over the page. So exercise 3C, question 6, 7, 12 and 13. And then in exercise 5.8 from the textbook, we're just going to do a couple from there, okay? So exercise 5.8 from the textbook, I'll just pull that up now. If you could just do question, I'll get you to do question 4 and question 6 and question 7. So exercise 5.8, question 4, question 6 and question 7. Okay? And yeah, the rest you don't need to do those. Okay? So as I said, exercise 3C, those questions, exercise 5.8 from the textbook, questions 4, 6 and 7.